E is a number that is irrational and it goes on forever. It's named after a mathematician by the name of Leonard Euler, whose name started with an E. It's spelled E-U-L-E-R. It's a number that's used a lot in banking formulas and a lot of other things related to calculus and things along those lines. So what we're going to do with this is round it to different places. So the first problem says round to the nearest whole number. Whole numbers ignore decimals, so we're going to round it right there. When we round it right there, we're going to chop it off right there. When we chop that off there, we look here and we say, well, 7, of course, is bigger than 5. 5 or bigger, so we round that off. So if we're going to round this off, then to the nearest whole number, we would say that E is approximately, because it's not exact, of course, because we're rounding, E is approximately 3. That's a terrible approximation. Okay, so there's the first one. And then we come to the next one that says round to the nearest tenth. Well, each number, each digit is 1/10 of the one before it. So here, that is the ones place. That's a tenth of it. That's a tenth of a tenth. That's a hundredth, a thousandth, a 10,000th, and it keeps on going. So we're going to round it to the nearest tenth. And when we round it to the nearest tenth, we're going to be rounding here. So we look there. We're going to chop off everything from here. You know this. But basically, if this is a 5 or greater, then we would round that up. So we're not, so 2.7. So in this case, we're going to say that E is approximately 2.7. And the reason we're doing this and going through this really drastic, painful review is so we can get the hang of which decimal place is called what. Because sometimes we kind of tend to forget that if we're not careful. And that's going to help us when we convert from from decimals to fractions. So let's erase our little orange mark here. Let's go to the next one. We're going to round to the nearest hundredth. That puts us here instead. So we're going to chop it off after that 1. Well, that 8 rounds that up to a 2. So we will say that if we're going to round to the hundredth, then E would approximately be 2.72, which is a much better approximation. So let's keep going. We're going to round it now to the nearest thousandth. So tenths, hundredths, thousandths, 10,000ths, tenths, hundredths, thousandths, 10,000ths, tenths, hundredths, thousandths. So I'm going to round it off there. I wrote on the border of my dry erase board. That's okay. It'll come right off. And so we will have thousandths. And in that case, E would be approximately 2.718. That doesn't bump up the 9, so bump up the 8 to a 9. So it's 2.718. There we go. And then we get to 10,000ths. So tenths, hundredths, thousandths, 10,000ths. There's a certain rhythm to that. Tenths, hundredths, thousandths, 10,000ths. And in that case, E would be approximately, I'm not going to draw it this time, tenths, hundredths, thousandths, 10,000ths. We stop after the 8. The 1 doesn't round that up. So it's 2.718. Oops, I did that wrong. Tenths, hundredths, thousandths, 10,000ths. I did it wrong. I went too far. Sorry. See how easy it is to mess up? Oops. Tenths, hundredths, thousandths, 10,000ths. So we're going to stop there. That 8 rounds that up to a 3. So we'll erase that. We'll make it 3. And then we skip a little bit. It's going to go to the millionth. So tenths, hundredths, thousandths, 10,000ths, 100,000ths. What comes after 100,000? Well, 100,001. No, I'm kidding. Tenths, hundredths, thousandths, 10,000, 100,000, million. So this is the nearest millionth. So if I'm going to round to the nearest millionth, then I would say that E is approximately tenths, hundred thousandths, 10,000ths, 100,000ths, millionths. Keep this, 8 rounded up though. The 8 rounds that up to a 2. So 2.71828. That bumps up that. There we go. Tenths, hundredths, thousandths, 10,000ths.
I got tens, hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, hundreds. You round tens, hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, 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 hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, hundreds, thousands, 10,000s, tenths, hundreds. You round it. You round hundreds, thousands, 10,000s, tenths, hundreds.
Let's write each of these decimals as a fraction or a mixed number, and we're going to reduce completely. So let's go ahead and start by just naming it what it is. This is 1/10. It's in the tenths place, so 1/10. There we go, done. That was easy. Okay, then we get to this one, and we have 1/7 and 1/100. Well, let's not do that. Let's just take the whole thing all at once and go to the last place. So 71/100. 1 71/100. This does not reduce. There's not a number other than 1 that goes into 71 and 100 evenly. Not an integer anyway. Okay, let's keep going. Let's go over to this one. So 1 and, let's see, tenths, hundredths. We've gone over to the hundredths. So 72 hundredths, and this is correct, but it can be reduced. And I know that because both 72 and 100 are even. Sorry, didn't mean to bump the camera there. So what we're going to do is go 1. Let's see, 1 goes into 72. I'm sorry, 2 goes into 72 36 times. 2 goes into that 50 times. Oh wait, there's more. 2 goes into this 18 times. 2 goes into that 25 times. There is not an integer that goes into 18 and 25, so we're done. It's 18/25. 1 and 18/25. There we go. Okay, whenever we encounter something that is a repeated decimal, like this one, then what we need to do is, instead of putting it over 10 or 100 or whatever, drop it down 1. So put it over 9 or 99 or 999. Okay, so we have 1 and 72 over, it is hundredths, yes, but because it repeats, this is the best explanation I have, but because that repeats, technically this is 1.72727272, because it repeats, it never actually gets where it needs to go. So we can't quite get to 100. Don't put 100, put 99. Not quite there. That's a terrible mathematical explanation, but that's the best one I have at this point. So what we're going to do is reduce this. And here's what I noticed. Let's see, 9 goes into 99, and 9 goes into 72. So we have 1 still, kind of hangs around. 1 goes into 72 8 times. 1 goes into 99 11 times. We have 1 and 8/11. If you typed 8 divided by 11 in your calculator, you'd get 0.727272. It might have 73 at some point because it would round it off when it finishes displaying it, but technically it keeps repeating. Okay, this one is 414, hold on now, tenths, hundredths, thousandths, tenths, hundredths, thousandths, so 414 thousandths. So now we're going to reduce it. Well, I know a number that goes into this one that also goes into that one, that would be 2. So let's do the easy part first. When we divide that, we get 500 on the bottom. In the numerator, we're going to get something that's not quite as obvious. It's 207, but just in case you need to see it, 2 goes into 414, 2 goes into 4 twice, 2 goes into 1, none at all, 2 goes into 14 7 times. So 207 over 500, and actually, that's as reduced as it gets. How do I know? I'll tell you how I know. Thanks for asking. The only prime numbers that go into 500 are 2 and 5. Now you could say, well, 10 goes into it. Yeah, I know. And 100 goes into it. Yeah, I know. But 10 is the product of 2 and 5. So what I'm really going to do is see if 2 and 5 go into either into that, and they don't. 2 doesn't go into 207 evenly. 5 sure doesn't either. So we're done. It's 207 over 500. If you typed that in your calculator, you'd get that as an answer. Okay, 5.4. This was not going to be so bad. So 5 and then 4, what decimal are we on? Tenths. So 4 tenths. Well, that reduces. 2 goes into 4 twice. 2 goes into that 5 times. 5 and 2/5 is what we have. Okay. Well, don't let the 1,000 fool you. It just sits around. 1,000. And then tenths, hundredths, thousandths, 10,000ths. So we have 12 10,000ths. Watch your zeros. Be careful here. I put this problem in here because I wanted us to see all those zeros. It might be a little overwhelming, but that's what it is. So be careful with the number of zeros you have. That's 10,000ths. So tenths, hundredths, thousandths, 10,000ths, and then 12 over 10,000. We can reduce that. The 1,000 in the front stays, of course. And 2 goes into this 6 times. 2 goes into that 5,000 times. And then we can reduce it again, actually. 2 goes into this 3 times. 2 goes into this 2,500 times. And I wanted to point out here, we spent a lot of time reducing this. Divide it by 2, divide it by 2 again. You could have divided it by 4 from the very beginning. 4 goes into 12, 3 times. 4 goes into that, 2,500 times. 3 goes into itself, but 3 doesn't go into 2,500, so we're not going to go any further. How do I know 3 doesn't go into 2,500? Well, because I said so. Well, also because 3 doesn't go into 25. And if you were to add the digits of this together, you'd get 7. 3 doesn't go into 7. So 3 over 2,500. 1,003 2,500ths. Okay, we have 8 and 81. Okay, normally we'd say tenths, hundredths, but we're not. We're repeating. So we're not going to do 100. We're going to drop it down 1. We're going to subtract 1. It's going to be 99. So 81 over 99. And we can definitely reduce that. We still have the 8. And 9 goes into 81. 9 times. 9 goes into 99 11 times, and we have 9 divided by 11. So 8 and 9/11ths on this one. We'll put our answer in a box. I haven't been consistently doing that, have I? Oh well. There's that ugly heart. There we go. All right. 7.222222222. So 7 and 2 over what? Well, this is normally tenths, but it repeats. So don't put 10, put 9. And that does not reduce. We're done. The rest of this page is up to you.